going to be a panel with all of the last few speakers, but moderating it will be Brian Crane from Chorus One. So he's the co-founder and CEO of Chorus One, and they're one of the leading staking providers with over $1 billion in staked assets. And he's also vice president of the Interchain Foundation and co-founder and co-host of the Epicenter podcast and a board member of the Urbit Foundation. So if we can, if all of the panelists can please come up, that would be great.
Cool. Well, thanks so much for taking the time here so we can talk about this. Yeah, I feel like this is a very interesting topic. So I kind of come from crypto. I guess this is true for a few here, right? Maybe some have had a different path, but in crypto, this feels like something people don't really think that much about, right? Like we think a lot about, okay, there's this consensus, there's this blockchain, it has some trust assumptions, and we can see it's decentralized. You think about proof of work and proof of stake and the game theory, and then when you sort of look further down and you look at the software and the trust assumption, how is it run? It is something that it's not really on the radar of most people building Web3 application and crypto applications. So I think it's really cool that we have that discussion here, and that you all sort of in different ways are working and approaching that. So I mean, maybe we can start actually with Jenny, since all three of you have already given talks, so I think people have some awareness of your projects. But maybe can you introduce yourself and talk a little bit about, so what are your thoughts on local first and P2P applications and why they are important?
Yeah, so I'm Jenny. I guess kind of coming from the crypto space, mostly like the crypto application space. I've worked on MetaMask, Aave, Lens, a few other projects. I think one of the things that made sense to me when I first got into crypto was that these things, P2P technology and crypto, seemed linked. And I think, as Scott in the beginning kind of talked about, we've a bit strayed from those roots in crypto, and it's nice to see it coming back to these things. I think the platonic ideal of what people are building in crypto and what we're kind of talking about today is that all of these applications do have some P2P component by the end of the day, right? If you really truly want to build an unstoppable application, you need to be resilient. But I think in your talk as well, Alexi, bringing up this idea that privacy and then the tenets of P2P networks are kind of at odds. I think that's an interesting thing that we could maybe talk about in this panel. It's something that's super interesting to me, at least. So, yeah.
Like privacy and the relationship.
Yeah, just how privacy and P2P networks can sometimes be at odds, and how it's kind of difficult to merge the two. Just one concept.
I'm interested in that. Can you flesh it out a bit more about how do they come in conflict?
Right. So I think global state and then a private network are kind of just at an application layer. They're just hard to how do you say marry? But I don't know.
There's also just the fact that in a peer-to-peer network, your node ends up talking to a lot of other nodes, which means your IP address is probably divulged. Your patterns, whether you're online at night or day, or your geolocation, all those kind of things. Whereas with a centralized server, you would only divulge that information with a single entity. So, in some ways, peer-to-peer networks are much harder to make private than centralized networks. Then of course you have you have to have things like end-to-end encryption. Transport encryption is not enough in a peer-to-peer network. So the problem of privacy is a lot harder to solve, I think, in a peer-to-peer network than in a more centralized network.
Did you want to? Yeah.
Yes. So So one aspect of this is, so it's possible to create private peer-to-peer networks where you only talk to the nodes, people you care about. But the problem with this is you typically want asynchronous communication, so that maybe not all your collaborators are online at the same time. And so for this purpose, you need to have some nodes that perform some relay, store and forward storage operations in the network. And you could pick somewhat trusted nodes that you trust for following the protocol correctly. You don't have to trust them with your data. But at least if you do not have to deal with the whole world that want to attack your protocol and data, yeah, I see this as a possible way forward.
Cool. So maybe we can go here next. Like Alexis, I'm curious if you can talk a little bit about, with Radical, when you guys sort of architected and designed what you're building, what did you feel like, okay, this is something where, blockchain and consensus is needed, and these are things that, they're not needed, and you're going to try to do it in some kind of, maybe just peer-to-peer between different peers without consensus, or just locally? Like, how did you kind of approach the design of this?
Yeah, I think it's interesting because as soon as you start to rely on a blockchain, you have kind of all of the infrastructure required to verify that data that you end up depending on, right? And that infrastructure, at the minimum, is a light client. But for networks like Ethereum, where light clients are still not fully developed, you end up relying on a lot more, like either a full node or a trusted third party or something like that. So I think that the big problem and the big question, and the reason why we didn't want blockchain technology to be kind of a fundamental dependency of the core Radical protocol is that we didn't want that really big dependency and that kind of more complex security model, essentially, where you have to think about, like essentially chain verification and everything that comes with that.
And then where it is still used, though, so can you describe what are the parts where you're still relying on blockchain and you're using it on chain?
Yeah, there are no parts that are kind of core in the sense that we rely on a blockchain. We're looking at, there's one fundamental problem that is, to my knowledge, unsolvable by a peer-to-peer system, and it's key rotation. So if you lose your key and you want to essentially say, hey, I don't have this key anymore, I don't hold it anymore, please invalidate it from this point in time forwards, that's not possible without a central authority or a blockchain, which is essentially acting as a central authority.
That sounds right to me. So yeah, Urbit has 32-bit and smaller addresses are stored on chain, like their ownership information, and then we can rotate those keys. For 64-bit addresses are each owned by a 64-bit address, so they can do that too by using the 32-bit address that's the owner as the authority. So that's essential authority there. Then 128-bit addresses, which we call comets, are effectively anonymous, and you can't rotate the keys for those. They're self-signed. So that's, yeah, I think that's a fundamental, I agree, fundamental limitation.
And yeah, just to close that thought, for that, we're looking at various ways to do key rotation on chain. One option is single-use seals on the Bitcoin blockchain. The only reason to use Bitcoin would be that the light client technology is much more light and portable, but an Ethereum solution would also work for that.
Yeah, I mean, it is interesting, right? That I think both Radical and Urbit have a sort of like similar, like very, very minimal reliance on blockchain, and then kind of used for a similar thing. I'm curious, with Urbit, I guess this was started like pre-blockchain, and it wasn't, wasn't part of the original design.
That's right.
Do you know, like, what was the sort of decision process to use Ethereum and to use the blockchain there?
Yeah, so the decision was made shortly before I joined Talon, so I wasn't in the room, but I've talked to a lot of people who were, and I do remember the pre-blockchain Urbit PKI, and the general idea was that it would be like, if you wanted to buy an address, it would be like buying a house, where you'd find an escrow agent, and just, it'd be the idea was, well, you could deal with this because it was a low volume of transactions. It's okay if you have to wait a little while, and so there wasn't BFT in a strict cryptographic sense, and the thought was, well, do you really need it? And also, there was no way to get it. So there's sort of like, all right, well, you just have something, and yeah, there were problems where, so there was some discussion, I remember, before Ethereum about what happens if somebody does try to sort of double spend their identity. And you end up with effectively a forked network where half the network thinks that somebody has this key, the other half thinks they have this other key. So we never really found out whether that would be viable, but it seemed like it was going to be difficult to make it viable. And the thing that a blockchain really does is it makes it so that even if somebody does try a double spend, the network resolves, right? You get a shared answer eventually. And so that kind of consistency going forward, that's if you don't have that, then you end up with this kind of mess that just accumulates. So, so the decision was made to switch to a blockchain, and actually it was interesting because at the time, the decision was made around 2016, 2017, and at the time, most Urbit people were highly ideological Bitcoin people. This is no longer true, it's much more of a mix. So the decision to go with Ethereum upset a ton of people because they're saying, well, why don't you do this on Bitcoin? And the answer was, we'd love to, but we can't. It just didn't support it technically. And I think still probably doesn't, although the ordinals get really close. So, but yeah, it was a purely kind of practical decision. It's like, okay, well, we have to put this on chain somehow. What chain can we put it on? Ethereum seemed like just sort of most likely to succeed at the time. That was the decision-making process.
Cool, thanks. Yeah, you wanna?
Yes, I would like to comment on this blockchain topic. Since in the Lofire design, there's blockchains are used in a different way, such that for local first collaboration on data, we use these replicated data types that are mergeable, and actually these have very similar needs as the blockchains for economic transactions. But there's a difference that so we have transactions on data, and we have data operations inside the transactions, and the execution is done locally. So every user is running the execution. So so it has all the data locally all the times, and this is very similar to DEX structured blockchain, where it is the same, but the network and the execution happens in a different way. And also consensus is not required to establish a total order, but if you want to make snapshots on data to be able to delete past transactions, you need some consensus on this. But so that's why I find it interesting to draw this parallel and perhaps have some collaboration in different research in this research field from different fields. Yeah.
Cool. So I want to switch topics a little bit and sort of ask the question, and maybe this kind of two related questions. I don't know which order to take it. So one is, what are the kinds of applications where this kind of local first in peer-to-peer is one, maybe most viable, right? Like we can actually build applications that work really well for those use cases. And maybe two, also it actually gives benefits to the users where they want to use that application, not for ideological reasons or because they like that it says peer-to-peer or something, but because they really confer some advantage and better user experience, better benefits than a kind of traditional centralized application.
Yeah, I can go. Yeah, I think if you look at the state of the world, like one of the problems people are having with non-peer-to-peer applications, they're around identity often, right? So people's identity are owned by certain platforms, and then when those platforms ban these users, they lose their identity, a lot of data, connections, network, and everything. So I would say like that's maybe the first place to look. So it's where, what kind of applications center around user identity. So probably, yeah, social networks benefit a lot. Everything to do with communication, because again, that's something that is censored, that is banned in a bunch of countries. Yeah, that's kind of where I would start. And then, the topic of this reunion of collaboration would be the third level, I would say.
Yes, I would agree that owning identities is important, but also local first comes into play for all cases of collaboration within organizations or informal groups. And one aspect that's particularly useful that centralized platforms often cannot do is the ability to work asynchronously and also offline. For example, like if I want to make my slides on a plane, I cannot just do it if I use a HackMD pad, because I don't have the network. I have to copy-paste the whole thing into a local file and then put it back when I'm done. And yeah, these kind of use cases come quite relevant and provide more functionality than centralized servers allow.
I would say that in addition to, that's the sort of the first clearest use case for any kind of decentralized technology and censorship-resistant technologies, something where people are expecting to be censored. It's like, yeah, you'd better use something where that fixes that. But in addition, for people who aren't worried about that, there's another practical issue, which is extensibility. Right? I mean, a lot of services that we use don't have open protocols. Very few of them do. And even if you were to reverse engineer the protocol, build a different client for, say, Instagram, TikTok, it's usually illegal to do so. It violates the terms of service. And if you have to, if you try to distribute an app in, say, the Apple App Store that has a different Instagram client, Apple is beholden to the U.S. government. And the U.S. government says it's illegal, so that they won't let you do it. And you even see this with things like, I don't know exactly what's going on with like Signal and MobileCoin, but my understanding is that they've only rolled that out in certain countries, and I think it's probably for regulatory reasons, right? And there have been, I think Discord at some point also tried to, add crypto integration, but then they rolled it back for a while because they were also worried about regulation, right? So anytime you have an application that people are using where there's a central server that you have to use in order to use the application, then there's a, well, it's that and the client distribution both, right? But either of those issues can make it so that you as an individual user can't just sort of add a plugin, right? You can't just kind of like add a calendar plugin to Signal or add like a Google Docs type collaborative editing system, right? So so I think that actually these peer-to-peer technologies should allow that kind of extensibility where like I as an individual user or like we as a small group of people can say, all right, let's install these other apps, these other plugins, configure things ourselves, fork the code, and have that kind of autonomy of which software we're running as an individual or a small group.
Yeah, I think there's also an interesting like local first desire for people running LLMs. I think this is like a relatively new local first use case, but I'm definitely interested in it. I'm definitely interested in being able to use these tools, but not have them shared with certain service providers.
On the topic of extensibility, I think an even broader way of seeing it is like open source software that runs on the desktop, like Vim or Emacs or whatever. These programs have existed for decades, and people are still using them and extending them and improving them. And it's the kind of thing that is so core to your workflow, your day-to-day, that you don't want that like Vim to be like acquired one day and then you can't use it anymore, right? But that doesn't apply for services that we're using right now, right? Like GitHub or Gmail or whatever people use. These are services that could be shut down at any point because the company runs out of money or it's acquired and shelved, or it changes in a way that, it doesn't serve your purpose anymore. And it would be nice if that weren't the case. So it would be nice if you could keep using all of your tools and all of your services for as long as you want. And that's only possible, I think, with peer-to-peer and local-first software.
So I would also highlight the notion of resilience in terms of networking. So for either censorship resistance, ban resistance, or even just in case of a natural disaster when the infrastructure is wiped out, it's useful to be able to still have some sort of communication going on. If you have a mesh network, you should still be able to exchange data, collaborate, communicate without going to a centralized server, which is not available. And one crucial requirement for this is to have asynchronous networking support. So you should be able to communicate asynchronously in the network, and then you can either put these data packets on a mesh network or through a mixed network or depending on your requirements. But if we have this primitive of asynchronous messaging, that would allow much of this.
And what are the limitations here? I mean, like, what are the things where actually, you know, it's like, no, you are going to need basically a kind of SaaS type infrastructure because it's just, you know, so much better. And yeah.
I think this is a very interesting question. And so, and I've thought about it a fair amount the past couple of years. I'm not sure I have an answer, but some things come to mind pretty immediately. Something where, like, I think Uber, for example, would be very difficult to replicate in a decentralized manner. Because you have to do a lot of like real-time calculation that involves you know, a lot of, you know, data from a lot of different sources, right? So you really kind of want, just sort of naturally, you want to do that, and like you have one big cluster that kind of runs this, right? And so if you imagine that sort of becoming diffuse, and you have lots of different people trying to figure out where they should all drive, it seems like it would be harder to do that. And you could make a similar argument for something like Amazon with its distribution services, that like the fact that they can sort of do a centrally planned economy where they have all of the information available to them, right, like means that they can maybe get a more optimal route, or maybe it's easier to structure, you know, a set of like batch algorithms to run to figure out like what route some driver should take, right, or where to store inventory at some given time. But conversely, I think that even those applications, despite being more difficult to run in a peer-to-peer manner, if you were able to do it, then I think you could actually have them run potentially a lot better, right? So much like in the 20th century, you had a lot of centrally planned economies that really didn't do very well, right? More or less, right? And then free market economies have a tendency to do quite a bit better, right? It's because you allow like an evolution of different strategies, where you have different people, maybe you have different drivers using different algorithms, pooling their resources together, right? Figuring out where to go. So you could imagine a lot of these sort of giant centralized services at the moment kind of evaporating and becoming like a neutral fabric, right? Where there's a protocol for somebody saying, hey, I'm a driver, I want to be in this area, and you know, I can set my prices the way I want. And same with a rider, so you need these kind of marketplace protocols. And I don't think that really exists yet. But I don't, and so it's maybe a little sci-fi, but I don't think it's impossible necessarily. And then if you had something like that, then I do think you would create a lot more economic value. And like if you think about Airbnb, they take 20 or 30, I think that, what, 20 or 30% cut?
Something like that.
I think Uber takes even more, right? So you have this one entity that's sucking just a lot of economic wealth out of the system continuously. Now they do apply that largely toward, you know, benefiting the platform itself, but you know, if you had just sort of a neutral, you know, fabric like infrastructure for running Uber, then you could probably just charge a lot lower prices, right? Because the driver, it's disintermediation, right? Where like you have a rider paying a driver directly, maybe there's a little bit of a transaction fee on a blockchain or something. But I think that's the long-term potential, even for those that are sort of hard to answer. I think it's still worth pushing on it and say, like, can we do these peer-to-peer?
I think it's an interesting example, the Uber one, actually, because what you're saying, this fabric, you could have global infrastructure for taxis, whatever, and then like in a way, all the times that you use a taxi, it's very local, it's very peer-to-peer, right? So there is this like, I don't know, I was thinking like while both of you were giving your talks, like I feel like Radical has been very purpose-built on like application and then finding like what technology can serve the building distribution of this actual application. And then with Urbit, it's more like maybe kind of platform style design for other people to build applications on top of. But yeah, I don't know, the taxi one is kind of funny.
One kind of interesting thing, because you mentioned LLMs for local first, but I think there's also a very possible future where the good language models are so big and require so much compute that they're running in the cloud, essentially, right? You have clusters of thousands of computers running like massive models, and the only way to stay competitive is to use those models, and there's no way anyone would be able to run anything on their laptop or desktop. So that's a possible future, which not necessarily desirable, but where you would need a kind of hosted service, I think.
Yeah, I think for a lot of things like that, there can be just a very large activation energy required to get out of the point where like something centralized is better. And then if you can get there, then you can kind of unlock more activity and value. I think, but it can be hard to do that, and not necessarily clear how to do that. So actually, there's an interesting historical example of IP and TCP. Van Jacobson has a really interesting talk about this, where he talks about, I think it's called thinning IP's waste. But he talks about how when IP first came into existence, typically communication protocols were all proprietary. There was not like one shared internet protocol. Each company and each manufacturer of a printer or whatever had its own proprietary protocol, and they didn't all share something. And so, kind of thinking about that back then, right? Then like this internet that we have now, where everybody speaks IP and TCP, like probably seemed like a pipe dream, sort of utopian, right? Like, wow, we can all agree on an open protocol. It's not proprietary. It's not patented, right? So I think that's actually a positive, a positive indicator that more of these things might be amenable to open protocols than we currently imagine.
Yes. So I would come back to this topic of LLMs. Well, I'm not an expert of LLMs, but what I found out recently that there are quite some viable open source efforts in this field that actually are promising to be usable. So let's see where this goes. But I would like to comment on this notion of what you can do with locally available data. So once you have locally available data from many sources, you can have a local database, you can do local search on this, and you can process it, index it, and put it in an LLM. You can have a graph database if you have graph data, etc. So one thing you might want to do in this case is, and what this enables, is local first search and discovery. So you can search your local computer first, and then your friends and trusted contacts, and then last tries to search the global network. So this kind of different layers, you can search with different trust levels, and so this is also where the trust comes into comes into play. Yeah.
Search, I think, is actually one of the hardest things to imagine decentralizing. Right, with something like Google Search, really tough. But I think LLMs actually might make it substantially easier, because they can have this they can have a fair amount of ballast of just sort of general knowledge. Right. So the crawling of the web may become a little bit less important proportionally.
So one thing I'm also curious is, recently the last years, and especially nowadays, right, there's a lot of interest and work around, ZK technology, and of course that maybe, so I'm curious, how does that intersect with this local first P2P applications? For example, Alexis, you mentioned, the need for live clients. So I don't know, to what extent ZK proofs can kind of get rid of this need for live client, or that you can run more locally, because even if it's local and you provide some sort of ZK proof of what was done, that maybe allows you to continue to, retain some of the assurances of doing it on chain, but while actually doing it locally. So I'm curious if one of you has some thoughts on that.
Maybe sort of tangential thought, again, around complexity, because I think if people are going to be running their own software, and this software is meant to replace a trust relationship with some kind of authority, then the software needs to be simple enough that people understand it and can audit it, right? And my problem with ZK is just that we're still, I think, at a phase where the libraries and the ecosystem is extremely complex and heavy. Most people don't understand the code. The code is usually not audited, and it's very hard to know if it's actually doing the thing you think it's doing. So sort of tangential, but I think that would be my first sort of resistance to it.
You have zero knowledge of what bugs are in there.
Exactly.
Well, I think there are a few ways that it affects the ZK stuff. The ZK tech could affect local first. I mean, it kind of strips away a number of things, depending on how good it gets. Right? It could strip away a number of sort of places where you need to use something like consensus. So if you imagine, like, there's a system called TrueBit. There's a computation market. And computation markets, I think, in general, people have been very interested in building these, but you had to have a very complex kind of game to, like, find fraud proofs and do, I don't know if they did probabilistic sampling or something, right? But without a ZK system there, it's difficult and complex to build something where I just pay you to run a computation, and then I have some reasonable amount of assurance that you ran the computation correctly, right? And that's not even really zero knowledge, but it's using the Starks or Snarks as a verification tool, right? Just like the ZK rollups, right? So it's not really for privacy, but for the scaling, right? Or like for sort of quick verification, right? That's an interesting thing where for example, if you were able to do this, you could have, if they were fast enough, you could have an ambient computation cache, for example, that's untrusted, right? So I go to run some computation, I just look up from my peers or some database and say, hey, has anybody else run this? And if I download the result and it comes with the proof and I can verify the proof in polylog time or whatever it is, then great. Like that's that could strip out a lot of intermediaries from a lot of different systems. But I think, as for the privacy aspect of ZK, I think it would make something like Uber potentially more doable, right? Because you don't really, if you kind of naively just use a blockchain to build some sort of market system and you expect some amount of pseudonymity, then, well, I'm just saying, hey, I'm a driver right here, come ride with me. And if that service is illegal, then the cop just signs up as a rider and then puts handcuffs on you, and then your service ends, right? So I think you would need some kind of blinding there, right? And so just sort of intuitively, that kind of blinding is where you might want to apply a ZK system.
Yes, I would agree with this notion of quick verification, and which would be quite beneficial for local first systems, because typically you are dealing with low resource mobile devices which cannot do large computations. So if you have tools that allow this more computational efficiency, then that would make also local first more viable.
Yeah, especially regarding my previous point about using blockchains, I think if a light client could just be served a proof of the state of the chain, and that state would include, like unique names or like identities or things like that, that would be a lot more viable than having to download, hundreds of thousands of headers or whatever it is. So in that respect, it could be interesting.
So there was this article a while ago by Moxie Marlinspike, right, who created Signal, and I felt, when I read it, I felt like, okay, this is probably the best critique I've ever read of sort of Web3 and of what everything that's being built. And basically, for those who haven't read it, he he does go and he builds some decentralized applications, and he just kind of looks at what are some of the trust assumptions in there, and he just noticed, okay, he built some application on Ethereum, and then it uses like Infura, and now I'm basically trusting Infura. Or the other thing that actually I thought was even more kind of shocking and weird was that he does this NFT thing, and then he basically, the NFT links to some kind of image, he changes the image, and he sells an OpenSea, and even in the description of OpenSea it says, oh, this is going to change the thing. He has some, I think, function that it changes it. And then OpenSea basically says, well, this is not cool, right? So they take it down. And the weird thing is that, of course, the NFT is on-chain, but all the other wallets are using OpenSea's API to show the NFT. So then the NFT disappears from independent wallets. So it's sort of interesting to think about, right, all of these Web3 applications. So maybe Jenny, we can start with you. I mean, you were working on Aave and like MetaMask, and how did you guys think about that? And where do you think this is going? Like, how are Web3 applications, like how are they trying to address that problem? And how do you think they will be able to address that problem in the next years?
Yeah, I think the thing that if you truly want to build applications that are, I guess, like, for me, the unstoppable is still like kind of the meme that I think is the most ideal. It's like optionality. I don't think that we've done a great job of it before, but I mean, obviously everyone has their own issues with MetaMasks. I no longer work there, I'm not taking them today. But like the idea that you can provide your own block explorer, like you can, provide your own network, these types of things, like they're small, but those are the important things that you have to give the user optionality about. The ability to run the front end yourself for a lending protocol, for example, the ability to, these types of things where you can empower the user to, okay, so we don't have a good peer-to-peer network yet, but you can bring your own service provider. That feels like an intermediate step, perhaps, in terms of like, I mean, Urbit has a good example of this. There are like hosted Urbit, right? But you can also do it yourself. So I think that is like the step that we're making. It's like progressive P2P, like progressive decentralization or something like this. And I think as an application builder, you kind of have to do that until we have really robust infrastructure. I'm not really sure like how many people are actually working on that level, right, of the stack. That's kind of an interesting question though. But yeah, I mean, for applications, the only way to do this well is right now is I think just providing options of different service providers. I don't think that's great though.
I would like to comment on this hosted peer-to-peer nodes, because I saw various different efforts in this respect from various peer-to-peer projects. Also, Holochain is doing this, and they do this hosted, like they have physical device you can put in your home, or you can host your node at a service provider. And I know that Orbit is doing this with Tlon and other providers. However, one critical privacy issue here is that you don't want your hosting providers to have access to your private data. So you want to have end-to-end encrypted data and messages, and the minimum amount of metadata accessible to these service providers. So so if you can figure out a way to do this encrypted storage and encrypted store and forward, then these become feasible. But I would also like to hear what Orbit and Tlon found out in this regard.
Yeah, it's certainly a flaw at the moment. I think that there are two potential ways of dealing with that problem. So one is that if let's say I have my Urbit planet hosted in Tlon, and I don't trust Tlon. All right, so they're running in Google Cloud, and maybe I don't trust Tlon, or maybe I don't trust Google, and I don't want any of my sensitive personal data that's in that relay, or like in my planet there, it's my node, so I could always pull it out, take the data out, or flag on chain, do what we call an individual continuity breach, and say, hey, everybody, I'm restarting the ship from scratch, And so, throw away all your connections with me, all your sequence numbers, and we're going to restart. So I could do that, and I could run it on my own machine after that, right? So I can always kind of reclaim the ownership there. But while I have that ship running in Tlon hosting, yeah, they can see it, right? They can see that data. They're running the computation, right? And so without some type of fully homomorphic encryption, that's a fundamental problem, right? And so there are two ways of dealing with this. One is solve the FHE. That's hard. Another thing you could do is say have only like client-side keys, right? And so I could use my Urbit in the cloud as basically just a dumb storage device, or maybe a little bit more than that. I could bake in some semantics, but I could, for example, encrypt all the messages that I store on there in such a way that I can only decrypt them with a set of keys that I keep on my own devices. Right, so I have keys on my phone, keys on my laptop. Maybe I do some kind of QR code thing to share and have backups, but only among my clients. And maybe I do encrypted backups of those keys in the cloud, and I just have to password or something for grabbing those keys. But then all the data that's stored in the cloud is encrypted so that only my devices can store it. So that's limiting because then that relay that I have in the cloud, or the ship that I have in the cloud, becomes basically a dumb relay. Right, I can do a lot less with it. So it has user experience problems from this. Maybe they're surmountable, but there's some issues. The way to get the other option, right? I don't think that like sort of taking the whole computation and transforming that into homomorphic encryption. I don't think that itself is feasible for a personal computing in general. I think it's just not anywhere near fast enough, like orders of magnitude too slow. But one thing you could do that's very close to that is you could use a secure enclave. Right, so unfortunately, secure enclaves, as they are very limited. You can't you can't have that much RAM associated with them. They're very difficult to use. They have security problems. So you can't really rely on that at the moment. So it's a bit of a science fiction answer, but it's much less of a science fiction answer than the fully homomorphic encryption. I've talked to some people building hardware, and they said that you could take a RISC-V architecture, design a custom chip that had a real secure enclave that was designed not for DRM, but designed for verifiable computing. And then you could put several gigabytes of RAM inside that secure enclave, but you'd have to design a chip. They said it would be about a 3-year project, but it's not research. It's just something you'd have to dump some money into. So I think that this has always been sort of the way I've thought about this with Urbit, is that if we get big enough that there's actually enough capital to put into that, then yeah, take the 3 years, put in some number of millions of dollars, and at the output of that, get a secure enclave, and then Tlon. I don't have to trust Tlon. I just have to be able to sort of audit the hardware supply chain to check that the key was actually secure.
Yep. Yeah, I mean, in the Lowfire project, I've been exploring this this option of using the relays as dump storage device, only encrypted storage, and I think you can do quite a lot with this, and this seems like the most immediately feasible solution. So I think it's worthwhile exploring what we can do with this, and the other options require much more further research. So.
Cool. I think we're pretty much at the end of our time. I was thinking of like, okay, should there be some sort of last thing of like looking forward, and let's try it. So I don't know if things if we manage to do this stuff right, if these technologies succeed, where do you guys hope that will be in 10 years?
I would hope that almost all services that we run or that we use are run ourselves, right? So that the client-server model that we have of the current internet would mostly go away by 10 years from now. And that most of these closed protocols, closed source clients, will be replaced by open protocols, open extensible clients, and that by default, people, this is sort of culturally, I would hope that 10 years from now, most people who are sort of on the internet a lot will have as one of their sort of core values that they just expect to have local first. They expect to have privacy. They expect to have local autonomy, bottom-up autonomy. Because most people right now don't expect that. And so I think that's what I would really hope for, is that by 10 years from now, have at least a substantial number of people where that's what they're used to, right? Used to that kind of autonomy and privacy.
Cool. What about you, Jenny?
Yeah, I think like looking to the future, to me, the important tenets are kind of like openness and optionality. And then I also see, I don't know, some conception of that like people will really be more interested, or it'll just be a lot easier to have your own infrastructure at home for the internet. So like same way you have a record collection or a DVD collection, you just have all the things that you care about that are digital artifacts, but you just can always access them. And the other thing I think is like this local first, like watershed style networks instead of global networks. They're more like bottom up. I think that's like an interesting thing that we'll probably see more of, but it's hard to say. Sometimes it doesn't feel like the trends of the world are going in the same direction that the trends from this room are.
Yeah, I think we have to expect or instill a change of values and culture around the internet if we want to reclaim it. So it's not just about the technology getting better, but it's people accepting to run their own nodes, essentially. Like, I don't think we're going to have a bright future if everything is hosted by third parties, even if they're hosting peer-to-peer nodes. Like, it's kind of contradictory, I think. So yeah, I think there's the most important thing is a change of perspective and value in every user. And that's what we should see.
Yes, in terms of local first, I would find important to have locally available data, all your data available locally. You can search it, you can change it, and still be able to synchronize it asynchronously with your peers. And this other aspect of just having the local networks and the global networks integrate seamlessly, so you can do your local collaboration and later synchronize it with the remote collaborators, and just the basics, and all this with privacy and end-to-end security.
Cool. Well, thanks so much, everyone. Yeah, that was great.
Thank you.